So I'm happy that today we have a representative of the university community. We have Petri Lähde, who will be speaking with us about energy efficiency in the ports. And Petri have been working in SAMK University for more than 10 years with the energy efficiency questions, with multiple solar energy projects. So let's see what's new about energy efficiency in the harbors. Petri, you're welcome.
Okay, thank you. Nice to be here. I've only been in the project this year, so there's a lot of new faces here. And yeah, today contents here, I'll be talking about the energy measurements first of all, and then how to save energy mainly in these small ports. And then briefly about solar energy heat pumps and a bit of automation, how can you automate things to save energy, and wind power. These are kind of related to the project, so what kind of investments we have been made. And then on the last, all the CB small ports project investments and a bit about the fairs that we've visited. So first of all, the key point number one there is that you need to measure things so then you know how much your consumption is. So by starting to follow the consumption, then you actually have some real knowledge what measures can you make to reduce the consumption. So like the electricity, now the prices have risen quite fast, and so then when you measure it and know where it goes, then you can start to save it. And also, of course, the water consumption, there has been, at least when I visited these ports, a lot of these leaking pipes and things like that, so wasting water is pretty common. And also, depending what kind of heating systems there are in the building, also oil and gas are used. So those, at least you can get from the bills that you pay, the amounts how much you are consuming. And then if you have district heating or similar, those should also be measured. So, of course, many of these are measured, but do you actually follow them and make like notes or do an Excel sheet or something like that? So you should have some kind of calendar notification, so every month or every week or how often you want to follow these up, so you don't forget to mark up and see how the consumption goes. And in Excel, for example, it's easy to make these graphs and things like that, so you can really understand what is happening there. And first of all, you should find all the existing meters that you have, and then learn how to read them. There are some differences in these and some common mistakes, for example, in water meters, some difficulties to read them. And like in the electricity side, usually there might be some kind of these accounts that you sign in, and then you can read all the, for example, hourly data there. So then it becomes pretty simple to see what's going on. And the easier the access is to all those accounts, then the easier it is to follow. So those, you should use those. And then in many cases there might be only 1 meter and all the buildings and everything is behind that, and that makes it quite difficult to know where the consumption is or kind of where the waste is happening. So you should have multiple different meters for more smaller sections, so then it's easier to find the kind of waste there. And there in the picture, it's from my home's electricity cabinet there. I have the whole house electricity meter down there, and then on the top I've added for the heat pump and hot water electricity meters. So I read these monthly. Maybe in the future I will add some kind of automation that will record the hourly data. But that really helps to know how much you're consuming and how to reduce it. And also, of course, in the bigger scale, maybe you don't want to measure all different heaters, but like at least in the building level. And here are a few examples of the measurements. I took this from also my house, but of course these will happen, or similar things are in your harbors. So first there is the yearly measurements, kind of getting a rough idea. Of course now when we are talking about one household, the curve goes, the longest one is in the December, and then it goes down, but in the harbor it usually goes up during the summer. I have a picture of that also. And so then you get the general idea, and then if you go to daily measurements, then you can see, for example, the weekend when you are using more, when you have more visitors in your harbors, and then if there's some big differences in days, so what is going on there, and things like that. And then if you go more detail, you can read the hourly measurements. So like here in the first there, this even section during the night. So then you can get the base load of the certain building or area, and then see what kind of machines there is always consuming, so like ventilation, something like that. And if it's high, then maybe there is something on, always on, some heater or something that doesn't need to be on, and it's all the time wasting energy. And then there in the center you see a few bars in the morning using electricity, and then we went to summer cabin at this case, and there was also low consumption during the day, and to evening consumption rise, and then the high bar there at the end is the hot water heater when it kicks on and starts to heat the water. So by looking at these, if you have some cabins or different buildings there in the harbor, with these you can see what kind of machines kick in at which time, and then maybe affect that if something is constantly on and it should only be in some times. So by reading these, you can find the problems. And as you know, the assumption is the mother of all fuck-ups, so you don't want to assume, you want to find out and check. So check the settings of your devices and systems and how they should actually work, and if they are set up correctly. And so there are usually some kind of timers and thermostats, so check the settings, and don't, of course, cooling in the summertime takes a lot of energy, and ventilation usually always on, and check the speeds and things like that. So these have kind of continuous, relatively high electricity consumption. And then, of course, during the winter time, when the places are closed maybe, so what are the temperatures that you keep there inside? And there's a few from different projects, a couple of examples. For example, this large shipyard, there were the temperature that was a couple of degrees higher than they thought, so they have set the temperature, but nobody had ever measured the inside temperature. So the savings throughout the year was roughly about 50,000 euros just to set the correct temperature. So everybody thought it was right, but it wasn't. And then also this one meat processing plant that they thought they had these heat recovery units in the ventilation systems, but when we went there and checked, there was nothing, so it's wasting a lot of energy when they are blowing out the hot or the warm air from the building, and the heat was not recovered. So these kind of examples. So you should always check these out. Then search these events when you know that some kind of device should come on or shut down, so if that really happens. and if there is some kind of anomalies, so kind of behavior that you don't expect, some random high consumption hours there, try to find out where that comes from. So then you find the devices that consume the most. And of course there are a lot of these user-based consumptions, so that you can't really affect them, but you could try to educate the people, but not patronize them. So kind of give some examples or something like that, how much some sort of energy consumption costs or similar things. And what you can do now, so first of all, of course, check the energy purchase agreements. So the prices have risen quite fast now, and if we, at least in Finland, we have multiple, like dozens different electricity suppliers that we can choose from and get different length of contracts with different prices, and you can usually change those pretty quickly. So check the prices often, and then you can do savings by that. It depends on the country, of course. And then check these extra heating things. So for example, if there's some electric heaters that are on, you should really do a checkup and go around all the buildings and places where you have these and check that they are set correctly and are not necessarily heating there. And for example, if you have these bathrooms, there's usually the underfloor heating, so also check that it's not too hot. So it shouldn't be hot on your feet, but only like so it doesn't feel cold. And then the ventilation systems, the clean filters often, so that reduces the pressure loss of the system and then reduces the energy consumption. And as these devices, they consume, consumption is not that high, but they are always on, so it adds up throughout the year. So also it's the air quality question, so that should be also check that the quality stays good. Then some things also, for example, these refrigerators and coolers and things like that, so when they are close to the walls, if you increase the air gap between the wall and the refrigerator, it increases the airflow and makes it consume less electricity. And also remember to clean those. And similar things go with the heat pump units, so clean the filters, things like that. So those are small, but again, these devices are always on. And then depending on how big the place is, there is so many of these devices, so the consumption will add up. And yeah, for the piers, there is a lot of these water pipings usually, and there is a lot of leaks or possible leaks, so check those. Like in the Kotka, we saw this pretty big leak too, but we don't take a picture of that, but there was a connection that goes to the pier, and it was like spraying water all around, so it was pretty bad. Yeah, so those should be checked fast. And then, of course, the LED lightings and things like that. So at least at these electricity prices, the payback time of LED lighting is very low, so you should change those pretty much immediately. And then after those, like the first steps, there are something that requires some more investment. So like the insulation of these hot water pipings and heating pipes, these will all the time waste energy, and it will heat up the space, and then you need more cooling. So you are kind of increasing the electricity consumption when you are making the hot and then getting rid of it. Then the water flows in faucets, so they are many years have been selling these low consumption faucets and water fittings, things like that, so showers and everything. So you can change those, and then that similarly affects for the consumers or your guests. So when they open the tap, it mixes usually air more to the water, and then it feels like there is a lot of water coming, but it consumes less. And of course, then you save from the water, and when they use hot water, it saves energy. And yeah, then finding about possibilities for you to utilize solar and heat pumps, wind power, and automation. I have some examples of these. And then, of course, renovating the buildings to be more energy efficient. So the windows and increasing the kind of making the walls better, insulations, things like that. And also adding the heat recovery systems for ventilation, things like that. And yeah, then when you have some kind of figures, so you have measured how much the consumption is, then you can compare these. So there's this best environmental management practices on the tourism sector, this European Commission paper. So it will give some guidelines about the energy consumption. And so, for example, there in the center is total energy consumption, and then you divide it by how many guest nights there is. So how many people are visiting or staying a night there, and how much energy is consumed. And then you get some kind of figure. So the goal there is about, or to be below 6 kilowatt hours per guest night, and then for 2 kilowatt hours or below is very good there. So there was this study in Germany. There were 99 different camping sites, I think, places where they measured these consumption and how many guest nights there were, and then these were made with that information. Yeah, then about the solar energy. So as we know, the small boards work mainly in summertime, and there's one small board from Finland and how the energy consumption goes there up throughout the summer. And so now also as the solar energy systems produce most in the summertime, so then it's pretty great fit to install these panels. So with the measurements, so as I showed the first pictures there with the data, so then you know how much electricity you are consuming during the daytime, then you can plan how big the system should be. But at least at these prices today, usually the bigger the system you can make, the better it is. So large panel systems are, at least at this point, at these prices, very good investment. For example, in Finland, the payback times have halved during this last year and this year. Yeah, and then you can also split the systems into many rooms, or many roofs. So if you have these southeast-oriented systems, then you get more in the morning, and southwest more in the evening, things like that. So depending when your visitors use the most energy, so you can again see those from the electricity consumption figures. So then you can choose what type of system, or then just depending how your buildings are set, maybe just one big, like in the background picture there, one big system. That is usually a bit more cheaper than making multiple in different directions. Yeah, then a bit basics on the on-grid PV system or this kind of grid-connected system. So these are very simple in principle. So you have some solar panels and then two cables coming, plus and minus cable from the roof, and they go into the inverter that transfers the direct current from the panels to alternating current. Then you have some switch there to cut the system off, and then the wire goes to the electric cabinet of the building. And from the cabinet it is used by the house or the building's appliances and things like that. And then there's the connection from the cabinet always to the through the meter and to the public grid, and from there you can sell the excess energy that you produce, and also of course buy energy when the panels are not producing. So very simple systems and easy to install pretty much anywhere. Then we have some other system types like these optimizer systems. So if you have these kind of a bit more difficult locations, so you have trees and things like that that make shadows, so then you could use these kind of optimizer systems that every panel has this extra optimizer box that kind of makes the best or the most out of the panel. So if one panel is shaded, it only affects that, because in normal systems the inverter sees the whole panel system as one panel basically, and if you shadow part of it, the whole consumption or the production will drop down. And you also get the single panel monitoring with this, so it's quite good. So if you have one panel broken, it doesn't affect the system, because it's in these systems, it's basically like you have multiple batteries in series, and if one battery breaks, it breaks the whole system. So there's the same basic idea. So you have many solar panels, and if you break one, it pretty much breaks the whole system. But with this, it doesn't affect that much. But yeah, you will get the information from the installers and the sellers of the systems. Then of course the batteries are one option there, but usually these are not yet that profitable. So it's case by case, but maybe in few years these will come also kind of like every time you build a system you will also add these batteries, but not quite yet. Yeah, then other investments in the energy efficiency. So these heat pumps are quite common, and it's been increasing pretty much. So the air-to-air or these common split units that you see in most places. So you have the outside box and then the inside wall unit there, and these are good for space heating and also for cooling. And with many models have these low temperature settings. So for example, in winter time you can set it to be like +7 or +10 or something like that, and it keeps that temperature inside, and it circulates the air and dries it up, so it keeps the place fresh even though if it's closed throughout the whole winter time. And then we have air-to-water heat pumps, so if you have a lot of showers and things like that, so these are good options there. And also these can heat the rooms. So if you have these water circulating heating systems, then these are good options. Then there are a couple that are kind of good technologies, but not very well suited for these small boards. We have the exhaust air heat pump, so you will need some kind of heating for the house, and then as the ventilation system draws the air out, it takes the heat out of that and then blows it outside. But of course in the winter time, if you want to keep the low temperature inside, so it's not really suitable for that. And also the ground source heat pumps, those are very good for large buildings, but usually if you have the buildings are not used that much in the winter time, so then it's quite a large investment and not usually feasible. Then of course the automation, there are a lot of simple things for like these movement sensors for lighting. So usually it's, if you're building a new building, it's cheaper to install these lights that have inbuilt movement sensor than it's to wire and put a light switch. So these are quite, the price is pretty similar to like normal lighting fixtures. And then of course these present detections for controlling the heating and ventilation and cooling of the room. So we don't want to cool or heat up the spaces that we are not using. But yeah, the automation, there is so many different things, so we won't be going that deeply there. Then a bit about the wind power. So in this project there was one wind power investment, and if there are high wind areas, like usually these small ports are near the seas, so there's a lot of wind, and then you get the most out of these systems. But compared to these large multi-megawatt windmills, these are usually not that great. The production is not that high. So there's the picture example there, the 6 kilowatt system, so produces about 9,300 kilowatt hours. Of course, it depends a lot on the place. And it needs quite a lot of wind, so roughly about 12 meters per second is usually when it hits the maximum production, and then from that on. But below that, the production is quite small. I have a couple of graphs of those in the next slide. So roughly 1,500 kilowatt hours per installed kilowatt there. But the good thing compared to the solar systems is that also nighttime production there, but of course usually it doesn't look that great depending on the place. And so this also goes well with the solar energy systems. So now usually when there's like rainy days, so then there's a lot of wind, then this can produce, and then when we have sunny days and not that much wind, then the solar systems will produce the energy. So usually, at least at this project, the prices jumped when the war started, so these are now quite expensive, and not everybody likes these, so it makes shadows and the flickers, so it's not that nice. And also it needs a lot more maintenance compared to solar systems, because there's a lot of moving parts. These are a few of the graphs. If you take the first one on the left there, the wind spot, you can see the bottom there, it's the wind speed, and the vertical axis, that is the power, and it goes on the maximum there at around 12 meters second, that's the peak, and there are also, you can see the height, so these come with different height poles, and then there are the diameters there, and depending on the kind of the ratio of the diameter and the height of the pole, you get the production in different points. So for example, the Aventa windmill there, it has quite large diameter, 12 meters of the blades, so then it goes, the maximum power is achieved in relatively low, around 6 meters per second winds. And then compared to others like the Iskra windmill there. Just so small numbers, can't even see myself. Around 11-12 meters per second. Oh, yes, which are the maximum powers there. Yes, just a few examples there, and then the green storm is the biggest one. So again, it's the maximum is achieved in a bit more lower wind speeds, but then the production is quite low compared to the investment in these low wind speeds. Yes. Then you can reduce the guest consumption there, so by metering all the electric hookup points, so then you can see who is consuming and how much, and you can also be ready for electric cars and boats there if you have the consumption-based billing, so that usually reduces the consumption. And then try to inform the people about saving water and use these good fixtures. Basically now, this is the list for these investments that we have made. So there are different partners that have made different investments and different ports. So we have this wind turbine and solar systems, building piers and electrifying piers and modernizing these power lines from air to underground. So if there's like storms, we don't lose power and things like that. LED lighting, septic wastewater pump stations, wind generator for one, smart lighting and things like that. So from here you can see most of the investments. I believe these are available, the slides afterwards. Yeah, so you can read from there. And then lastly, for the fairs that we have been in Kotka Meripäivät, we have been handing out these route books and then port guide books. So I believe total over 600 books what we have given to the people. And at least in the Uiva Boat Fair last weekend, there was a lot of interested people asking about these. They were a bit surprised that we give out these very good books free. So very good feedback about that. Yeah, that's pretty much what I had time to tell you, so thank you.
Thank you, Petri. Yeah, and indeed, thank you. Very detailed, I would say, technical presentation, but including all those tips that we somehow need to understand that, you know, everything is possible. And what I took as a little note is that it's very important to measure. And I think this importance of measurement is something that we can as well think in a broader matter about our work in general and see how we can measure the efficiency of the port and the way how we work and attract tourists. And of course, sustainability is a lot in the mind. So changing the habitude, thinking more green, thinking more, being more effective, all these things is something that we keep in mind. Thank you, Petri. Thank you once again.